reaches the highest point. When it reaches the highest point, its speed will be 0. So its kinetic energy will be 0. We will find the total energy on the surface of the Earth, the total energy at a height h, and use the conservation of energy to solve for h. Alright, let's do that. The mass of the object is 100, now it's a 1000 kilogram. So add another 0 there. Is 1000 kilogram. The velocity that you project that with, the initial velocity of projection is 5000 meters per second. Radius of the Earth is 6.38 times 10 to the 6 meter per second. This is a value that we need to use all the time. And GME, remember, wherever we find this quantity GME can be replaced by small g RE squared. Alright, GME is small g RE squared. Okay, what is the total energy of this object on the surface of the Earth? Total energy is its potential energy plus its kinetic energy. Now, the potential energy is negative g REM. Is that right? Well, let me refresh your memory on it. The potential energy of an object on the surface of the Earth is negative g MEM over RE, and that is, replace your GME by what quantity? Negative g RE squared M over RE, and 1 RE on the denominator and 1 RE on the numerator will cancel, leaving us with, oh, it disappeared, leaving us with this: the potential energy on the surface of the Earth is negative g REM, and the kinetic energy is 1/2 mv squared, where v we know. Now, let h be the height where the velocity becomes 0. As it rises, it's going to stop at that maximum height. Alright, what is the potential energy at that height h? The potential energy at that height h is negative g MEM over RE plus h. And what will be the kinetic energy at that time? Kinetic energy will be 0. Now, replace your GME by small g RE squared. So the potential energy at a height h is negative g RE squared M over RE plus h. And the kinetic energy at that height equal to 0. Therefore, the total energy will be this quantity. And this total energy must be equal to this total energy on the surface of the Earth. The total energy on the surface of the Earth is this: negative g REM plus 1/2 mv squared. And that must be equal to the total energy at a height h. That is negative g RE squared m over RE plus h. Now, you need to solve for h from there, and how will you do that? Well, what I will do probably is divide each term by m and maybe multiply each term by 2 so that the 2 from there will go. So that's what I've done. I have multiplied each term by 2 and divided by m. So dividing by m, this m will go, multiplying by 2, negative 2 GRE. Multiplying by 2 will eliminate the 1/2. Dividing by m will eliminate m, leaving us v squared. Alright? So I hope you follow my simplification. What I'm doing is multiply each term by 2 and divide by m. So multiply by 2 and divide by m. multiplied by 2 and divide by m. Now, this is what gives you m and m cancels. This is now negative 2 GRE. And in here, m and m cancels, 2 and 2 cancels, leaving a v squared, equal to what is now here. M and m will cancel. The numerator will be 2GRE squared and the denominator is RE plus H. So negative 2GRE plus V squared equal to negative 2GRE squared over RE plus H. Remember again, we are looking for H. So what will be your next step? Alright, you can actually put down all these values. Let's put down the values. Negative 2 GRE, negative 2 times 9.8 times, RE is 6.38 times 10 to the 6, plus V squared, this is the left hand side, equal to the right hand side, 2 GRE squared, 2 times 9.8, this is the radius of the earth, and you need to square it, over RE plus H. You need to now use your calculator to figure it out. Would you like to do that with me? Simplify the left hand side on your calculator and simplify the numerator of the right side. The left side gives me negative 1 times 10 to the 8. Alright, I hope you agree with me. Check it. The numerator on the right side, I get 7.9 times 10 to the 14. Alright, so negative 1 times 10 to the 8 equal to negative 7.98 times 10 to the 14 over RE plus H. The left hand side is negative, the right hand side is negative. You can cancel the negative signs, is that right? That means this RE plus H now equal to this quantity divided by 1 times 10 to the 8. You see how simple it became. And therefore H equal to this quantity can now be simplified and then subtract RE from there. The right hand side, when you simplify this quantity, alright, check it on your calculator. Do you get this as 7.98 times 10 to the 6? Well, if you get it, how do you find H? H equal to 7.98 times 10 to the 6 minus RE. And you know what RE is. So that is, now RE is 6.38 times 10 to the 6. So that is 7.98 times 10 to the 6 minus 6.38 times 10 to the 6. And that is 1.6 times 10 to the 6 meter. That is the height to which the object will go when projected with a velocity of 5 kilometers per second. Alright. It's a nice problem and you must be familiar with doing these kind of problems. Next one. A particle is projected from the surface of the earth with a speed equal to twice the escape speed. When it is very far from the earth, what does that mean? When it's very far from the earth, at infinite distance, what is the characteristic of infinite distance for us? When it is very far from the earth, at infinite distance, the potential energy is 0. That is the characteristics. Then what is its speed? Now, if the object is projected with a velocity equal to the escape velocity, when it reaches at infinite distance, its velocity will be 0. And also its potential energy will be 0. But if you project now the object with twice the escape speed, 2 times the escape speed, when it reaches infinity, it will still have a lot of kinetic energy left. We need to find the speed at that time. Alright, so let's start picking the data. You know that V escape, you remember we obtained an equation for escape velocity. V escape is square root of 2GRE, isn't it? Yes. So we projected our object with a velocity 2 times this. Therefore, velocity of projection, if you cannot read it, watch this. This is V projection, the velocity with which we projected the object. The velocity of projection is 2 times the escape velocity, 2 times square root of 2GRE. And what is the potential energy on the surface of the Earth? You must make this equation familiar, as accessible to you all the time. The potential energy on the surface of the Earth is negative GREM. Alright? What is the kinetic energy on the surface of the Earth? Kinetic energy is 1/2 mv squared, and the velocity of projection is 2 times square root of 2GRE. And when you square it, what do you get? Now, squaring 2 will give you 4, and squaring the square root sign will remove the square root sign. So, when you square it, it becomes 4 times 2GRE, right? And 4 times 2GRE will be 8GRE. And there is a 2 on the denominator. The 8 will go with 2, leaving a 4. Well, I have another step there. So that will be 1/2 m times 8GRE. You know how we got 8. And now that will be equal to 4mGRE. So the kinetic energy on the surface of the Earth is 4mGRE, and the potential energy is negative GREM. So what is the total energy on the surface of the Earth? The total energy is the sum of the potential and kinetic energies. That will be 4mGRE added to the potential energy minus GMRE, and that will be 3mGRE. This is the total energy of the object on the surface of the Earth. And now, we need to find the velocity v when it is very far from the Earth. Interpretation, when its potential energy is 0. So, if v is the velocity of the object at infinity, its kinetic energy will be 1/2 mv squared, and its potential energy will be 0. The total energy, therefore, at infinity is 1/2 mv squared. And look at how simple this problem is. The total energy on the surface of the Earth is 3mGRE. The total energy at infinity is 1/2 mv squared. Well, you can see all these problems are solved using conservation of energy. The total energy at infinity must be equal to the total energy on the surface of the Earth. So according to the conservation of energy, 1/2 mv squared equal to 3mGRE. And you can see m and m will cancel right away, and solve for v. Let's solve for v. We get v squared equal to 6GRE. Again, multiply by 2 and divide by m will give you this. Therefore, v equal to square root of 6GRE. And you know g is 9.8. RE is 6.38 times 10 to the 6th. That will give you that velocity is 1.94 times 10 to the 4 meter per second. That means when it reaches infinity, what does infinity means? Out of the potential well, it has this velocity. That means it will keep going forever with that velocity. Okay, another problem.